We have sophomore Linda Zhang, and she will be presenting her research project titled Towards Equitable Human-Machine Interaction, Large Language Models Address Data Scarcity for Code Mixing. Linda is passionate about natural language processing research and blends her love for linguistics with AI. She presented her work on machine translation in multiple published journals, and her recent work on code mix sentiment analysis was awarded second place at Synopsys Science and Engineering Championship. As an officer of Wisdom, Research Club, and Linguistics Club, Linda is dedicated to supporting others, approaching every task with enthusiasm. In her spare time, she enjoys creative writing, dancing, and gymnastics. So please give it up for Linda.
Hi everyone, I just want to start off by asking how many of you speak more than one language? Show of hands. Okay, cool. And when you speak those languages, do you ever mix between two languages at the same time? Yeah, so this term is called code mixing, and that's the main thing that my research strives to address. Alright, so introduction to code mixing. So essentially, code mixing is switching between one or more languages, or two or more languages, and it's important not just in our community, but around the world, say in India, in Mexico, in Singapore. And that's because we have very diverse and multi-ethnic communities, and we need to make sure that technology is able to address and recognize code mixing. Some examples are Spanish and English, and Chinese and English. And so when I was trying to find an example to put on this slide, the first thing I thought of for Chinese English is to go to the Harker WeChat group for parents, and I scrolled up about 2 messages and I found this message which combines Chinese and English. So it just shows how prevalent it is in our daily lives. And so the major issue is that mixed languages, like code mixed languages, are often only spoken rather than written, and there's not much data available to train machine learning models. And so as a result, machine learning models, such as the ones we know, don't perform very well on mixes of 2 or more languages. Okay, so past work. There's been a lot of past work on researching code mixing, but none have leveraged large language models, which are essentially generative AI such as ChatGPT and more. And the main methods that were used in code mixing were for sentiment analysis, which is to identify if a text is positive, negative, or neutral. And again, the problem was that there was not a lot of data to do this. So there's also been methods for data augmentation in code mixing, which is generating more sentences to make the data set larger. And the main ways people have done this is through linguistic theory or corpus conversion. And so linguistic theory just uses linguistic concepts, and then corpus conversion uses parallel sentences, say English and Chinese sentences, and for an English sentence, it picks random words to translate to Chinese, and it becomes a mix of them. The problem with this method is it doesn't consider that the switching points are intentional. It's not just random when things are switching, and it also depends on having a lot of parallel data available. And so I aim to find a new data augmentation method to apply to this task to improve the performance of these models. And this is important with the context of human-machine interactions because we want to make sure that machines can interact with all peoples, people who mix languages, multilingual speakers, not just monolingual populations. So large language models. So can an LLM learn to teach? Essentially, when LLMs were first created, it was really important that they would be able to do new tasks based on old information. So even though they don't explicitly learn how to do, say, sentiment analysis, it's important that we can teach them how to do this. And the way we do that is giving it a prompt. We just say, classify these conversations, for example, and give a few examples of the conversations, and then just giving this to ChatGPT, it can generate, say, a label for a new sentence. And so it learns the task without actually being trained on it. And it's because it's had experience with a lot of data and it understands the processes of our world. So the issue with this method is that a lot of smaller models that are actually trained to do sentiment analysis are better at it than just the LLM not being trained and just trying to learn how to do it. What can be helpful though is using LLMs for for pure generation. So instead of asking it to learn how to do the task, ask it to learn how to generate more of the task. So instead of generating a positive label for a new sentence, generate both a new sentence and a new label. So it's learning how to generate more sentences that can teach future models. And so essentially the LLM can be used for data augmentation. So the central questions of my research are, to what extent can LLMs be leveraged to generate high quality code mix text for data augmentation across various languages? And an additional thing I consider is how do factors such as model architecture, fine-tuning strategies, and training data diversity impact the effectiveness of code mix text generation? And so what do? So first, I come up with a prompt for the large language model, which is something along the lines of, we are trying to collect more data for this data set, could you please help out? And then these are examples of the current data set, which is code mix sentences and then their sentiment classification. And then we give it to the large language model, and then it generates responses that have a similar distribution, more code mix sentences and more labels. And now both natural and synthetic are used to train a task-specific model for sentiment classification. So this is really important to compare performance between natural and synthetic and then a mix to see if the data augmentation truly helps. And so all of these sentences can be like unlimitedly generated, so we can really increase the size of this data set. We only need to give a few examples and we get thousands and thousands more examples. So what's important during this process is we need to create a prompt that accurately reflects the natural data. And so I start out with an original prompt and I iteratively give it to the large language model to see its responses. And as I find new responses and new errors, I change the prompt depending on what I observe. And so the main things that I realized I needed in the prompts were, one, define an objective very clearly in the beginning, which is that we're gathering more examples for this data set. And then second thing that was very helpful was asking the LLM to pretend to be a human. And so I told it to pretend to be a bilingual social media user, so it could really like understand what a human would do if it was generating sentences. The third thing is to add demonstrations of the task. So I added examples of what a code mixing tweet looks like. And then 4, specify the outcome. So the volatility of the large language model outputs was did not help because it sometimes says different phrasings for a certain output. And so I specified the exact formatting of how to output the data. So now, experimental setup. Once I generated the additional sentences with the LLM, I trained another model based on natural sentences, synthetic sentences, and then both to see how much the synthetic sentences help the data. So specifically, I used Spanglish and Malayalam English. Spanglish was high resource with 12,000 data points, whereas Malayalam had only 3,000 data points. So it's also important to consider that the large language model is trained on 1.7 trillion data points. And so these are very low in comparison. And so I fine-tuned it, and then I also changed various parameters to see their impact on the overall system. So what were my results? So I found that this method is effective depending on the language. And Spanglish synthetic data improves performance by 32.9%. So I evaluated using unseen test data, and I found that there was a 12.6% improvement for 12,000 natural Spanglish sentences, and then it rose to 32 when the training set is really small on only 3,000. And then on Malayalam English, I found that it actually decreased results by about 10%, which I go into further. But what's interesting is that the Malayalam natural data with no added sentences got an 84.3 F1, which is the highest for this data set, surpassing the previous work by 6%. And I'll also go into why I think this happened. So some additional results I found that you can't just add an arbitrary amount of synthetic data. You need to choose the sweet spot between having too little and too much. And so if you have too little synthetic data added, it just doesn't make a difference. And if you have too much synthetic data added, then there's too much data that's confusing the model. And so I found the optimal data size was 15,000. And I also varied many other parameters and found results. So I wanted to see more empirically how similar the LLM and the human sentences were. So I asked two native speakers to annotate the data, 50 in natural sentences and then 50 in synthetic, and see the difference. And I found that overall LLM generated sentences are indistinguishable from human sentences. I asked them to annotate based on naturalness, which is displayed here, and the distribution was about the same. Both human annotators felt that around the same were natural versus unnatural. For label accuracy, how many sentiment labels that the human annotators agreed with, it actually found that the LLM labels, they disagreed with 0% of them, which shows that the LLM labels were extremely clear. And this is because the LLM was trying to generate sentences so that it could classify their sentiment. So it purposely generated more positive ones and more negative ones. Whereas in real life, humans just say things, they don't expect to get the sentiment out of them. And so it's a bit more confusing and mixed. I also asked the annotators to predict if something was human or machine generated, and they only had a 45.5% accuracy, showing how both sentences were very similar. So last I looked at the data that was from the training sets, and I aimed to answer two questions. My first one is, why did the Malayalam English baseline perform better than Spanglish despite less training data? And the main reason I found was that the Spanglish data inherently is ambiguous. And the reason for this is because human speech and human text is very ambiguous. For example, two tweets that both say like Happy Friday and then about this TV show, true labels were neutral for one and then positive for other, despite like the mention of happy. Whereas the model prediction was positive and then neutral. And it's really hard to tell here because it seems that this one could also be positive and this one could also be neutral. So inherently the data has some areas where the labels are ambiguous. And also in normal human language, sometimes we speak and there's sarcasm behind it and it's hard to tell if something is positive or negative or neutral or just a mix of all of them. The second question I was trying to answer is, why did synthetic data improve Spanglish performance while decreasing Malayalam English performance? And so I compared some human sentences and some machine-generated sentences, and what I found was that in Spanglish, the machine-generated sentences mimic the humans ones much better. They all centered around the same topics and phrasing. For example, a human sentence was like, sorry, something came up and I can't make it to the party. And the machine also generated, sorry, something came up, like for real. And it's important to note that this sentence may have never been shown to the machine, but they still revolved around similar topics. And another thing to consider is that large language models are more confident in languages it's seen more, such as English and Spanish versus Malayalam. So another quick interesting observation is that the LLM tends to generate code mix sentences about code mixing. So in much of the synthetic data, it mentioned Spanglish or code switching or bilingual or French. And some of the sentences the LLM generated was like, does this count as a code switch tweet? Asking for a friend. And I think I finally got the hang of code switching. It's kind of fun. The LLM, in a way, it has a personality for this. I told it to generate code examples, and what it thought of generating is, oh, I know how to speak Spanglish, or something like that. So it just shows that maybe it does have a personality. So the key takeaways of this research. So we found that GPT-4 is effective in mimicking topics, giving only a few examples, and it understands the intentions behind code mixing. It can produce colloquial phrases in Spanish, and it's confident in language it's more familiar with. Furthermore, I found that in Malayalam, there was primarily Malayalam with a few English words, whereas in the Spanglish data, it was more evenly represented. And in the machine generated data, it's better at generating more amounts of English than in the other language because it's trained on more of that. And so ultimately, my contribution is I'm addressing code mix data scarcity using a novel application of few-shot prompting a large language model. So I'm using this innovation that's inside the machine learning community to apply it to an outside really important task. And I also released the synthetic data on GitHub for future use. And just a recap of my results, in Spanglish it improved sentiment classification by 12% and above 26%. And in Malayalam it decreased performance, but I also gained the highest, newest benchmark for the data set. And some future work would be using different LLMs and different languages. And ultimately, I find that it's a promising avenue and LLMs should be used for code mixing in the future. And now my acknowledgements and references. And I'll open it up to Q&A. Yeah.
Could you go into a bit more detail about like the sweet spot for like the line of data? Like why it is too high, like confusing, as you said?
Yeah, sure. Yeah, so essentially the experiment is trying to test if the synthetic data truly has the same like distribution as the human data, if they're the same. And because we're testing on human data, we want the data that it was trained on to be as similar as the data that it was tested on. Now the issue with this is the synthetic data could be completely different from the human data. It might not be exactly the same like distribution. It might talk about topics that the test data doesn't talk about. And so if we have too much of this with too little natural data to balance it out, these might just skew results and make results completely bad. So synthetic data, it helps it learn code mixing, but it might not help it as much as natural data does because, well, it's natural. And so we want to add synthetic data so it learns a bit more, but not so much of synthetic data that it doesn't like understand. Anyone else have questions? Yeah.
Well, sometimes I feel like I say like part of a word in one language and part of a word in another language for like the same word.
Yeah.
So is there like a way that AI can kind of identify that?
Yeah, that's really interesting. So some examples of that in our data set was like text AR, which is like to text in English, but then using Spanish conjugation.
Yeah.
Text AR, for example, like text AR, it's not actually a word in either language, but it's a mix of the two. And another one is like chillar, like chill, and then using Spanish conjugation. And so what's interesting is the way the LLM did it was it also generated stuff with text AR. Like for example, these are the machine sentences. And the way it did this is that the LLM has been exposed to many humans who are like typing with it and interacting with it, and using that, it learns from them. And because text AR is commonly used, then it also generated words like text AR. So the benefit of this method is it's not based on any specific rule that might like eliminate other languages. It's just based on what humans do and its observations of code mixing before and what humans have done before. And so it's more natural in its generation. Yeah.
So I'm assuming you don't speak Malayalam, so
No.
how did you like was there a step for verification of like the validity of the data?
Yeah, so my main thing was just to see if it improves the data augmentation, if it improves the downstream model for the sentiment classification. I wasn't able to get like human annotators to look at it, but ultimately I found that when I was reading the data myself, even though I couldn't completely understand it, I found that the natural data usually only switches to English when they mention the word dislike, because dislike is commonly used in social media in English rather than in other languages. And I found that in the machine-generated sentences, it didn't do the same thing. It had a lot of English and then a few Malayalam words, and it didn't say dislike a lot. And that's the main reason why I saw the disconnect and why the performance decreased. questions?
What inspired you to sort of look at code mixing through the lens of AI? Like, why that combination?
Oh yeah, so I've always been pretty interested in AI, and then also in like linguistics, like computational linguistics. But what really caught my eye to it was my grandparents, because I live with my grandparents and they speak Chinese at home, and then my parents were from China, but then they grew up in America, and so while my brother and I primarily speak English, my grandparents primarily speak Chinese, and so I was exposed to a lot of code mixing between the two because my family is kind of like a mix of these two different cultures.
Kind of like using code mixing in like spoken languages. Do you think it's possible to like code mix in like coding languages as well?
In coding languages?
Yeah.
I would say not as common, or I've never seen it before, just because I think code mixing is more of just like when you understand a topic in one language like kind of better than the other, you like accidentally do it or you do it to express yourself. I think for coding languages it's more like black and white. You're trying to like achieve a
Would an AI be able to generate that kind of?
I think they would be able to. I just don't know the application for like generating two different coding languages at the same time. Yeah.
So how would you necessarily approach if you do another project but with like three like languages instead?
Yeah, so like if someone's code mixing three together.
Yeah.
I would test it quickly with the LLM. I wouldn't do like a large scale generation process. I would ask it to generate like 1 or 2 sentences and then test to see if it can actually do it, because I know 3 languages is not as commonly used. And if they can't do it that well, then I wouldn't stay with just the LLM method. I would look to other previous methods for how to do it. Maybe like get like a sentence in English, say, and then do the method where you use like a dictionary to translate one word into a different language and then another word into a different language. Maybe not this, depending on how the results look.
Okay, thank you so much for everyone's questions. Unfortunately, our time has run out. So thank you for coming and thank you for listening to Linda's speech, and great job, Linda.